acceleration is negative 9.81 meters per second squared. Okay, due to gravity.
Projectile motion is defined as two-dimensional motion and a free fall with an initial horizontal velocity. Here, we demonstrate a sequence where a soccer ball is rolled off a table with an initial horizontal velocity and underwent a free fall due to the velocity and the force of gravity. Josh will now perform a free kick in which the kinetic energy of the soccer ball will be shown. Measured in joules, the kinetic energy shows us how much work is being done on the ball after it is kicked. The formula for kinetic energy is 1/2 the mass of the ball, which is 400 grams, times our velocity squared, which is to be determined. We now multiply the mass by the velocity, which is 20 meters per second, and then we square that. The total kinetic energy is 80,000 joules, which is expected since the ball is traveling at such a high velocity.
In this video, we're demonstrating Newton's first law, commonly known as the law of inertia. What this law states is that an object will stay in motion unless acted on by an external force. Here, the soccer ball is staying in motion, or staying at a state of rest, because there is no external force acting on it. Here, the ball is moving because of Jake's foot being the external force. Hypothetically, if there is no friction caused by the turf, the ball would continue to move until the East River. Here we are demonstrating velocity, the formula being displacement over time. Josh will be kicking the ball from 11 meters out. Jake will be timing how long it takes. That's where we'll get our formula from. Our velocity is 3.0726257 meters per second, which can be simplified to 3.1 meters per second.
This is an example of displacement because the ball changes its starting position. In the first example, there is no displacement because the ball is passed twice and it returns to its starting position. In the second example, however, the ball is only passed one way and therefore the displacement is whatever distance in meters is covered by the ball between the two spots.
In this next experiment, we will examine the concept of kinetic friction. Surfaces with higher K values will cause the ball to decrease in velocity. We hypothesize that the snow will have the highest K value, followed by artificial turf and the concrete. Cut.
From our observations, we determined that the highest K value was snow. The next highest K value was turf. The lowest K value was concrete.
Here we are demonstrating potential energy. Josh will kick the soccer ball straight upward. As the ball travels upward, it gains potential energy. At its max height, it has its max potential energy before it travels downward due to gravity. Potential energy is measured in joules.
In this segment of the video, we are demonstrating the concept of momentum. Momentum is defined as the quantity that describes the product of the mass and the velocity of an object. Now, Gassy Rick will kick the ball, which is 400 grams, and at the width of the basketball court, which is 13.1 meters. And we will now calculate the velocity, which will be the variable that will give us our momentum, and the formula is mass times velocity.
We found that our velocity was 4 meters per second. making our momentum 1587.87 kilograms times meters per second.
The next highest K value
of the mass and the velocity of an object. Now, Gassy Rick will kick the ball for 400 grams with the width of the...
For our first experiment, our balls are dropping.
What?